Alright, so now we're talking about temperature control. We actually are going to explain the systematical how it actually works. It's kind of different temperature because it should detect the level of temperature in every room. The reference we take from Industrial Electronics by Frank D. Petruzilla. Now, if we're talking about temperature control, firstly we have to acknowledge what actually temperature control is. So temperature control used to maintain a specific temperature in a process or works as protection of extra temperature condition. Now there are actually types of temperature which are open loop, and the second one is closed loop. As you can see, the difference is in the system itself, the systematical on how the input goes into the output. So the difference is in the process itself. There is a significant difference between the closed loop and open loop. As you can see here, in open loop, there's only a controller and also the relay control. But there has to be a different systematical way in closed loop. You can see the difference. Now this is a type of temperature control. There are some parts there that are crucial that is put into these temperature control, such as process value. These process value indicates the value of temperature we are willing to set, and the second one is set value, indicates the standard value of the temperature. And then you can see here setting value, the red button. The setting value is for setting or adjusting the value of the temperature. And then also there is a feature of function mode, and of course there is navigation and a blue button here. Now if you're talking about temperature control, it relates to physics, specifically about induction heating. So induction heating is actually the process of heating an electrically conducting object, typically a metal, by electromagnetic induction through heat generated in the object by eddy currents. This is, as you can see, an example of induction heating. So as the heating occurs, there has to be a magnetic field around the workpiece. So this is actually a coil. So the way it could be possible for magnetic field to be appearing because there is a heating flowing through the coil. So it makes the workpiece. So it makes the coil throughout its magnetic field. So this is the basic, the fundamental material on how the temperature control actually works. Alright, so as we said previously, temperature control, we actually talk about the systematical how it actually works, starting from the input coming into the output, and also not forgetting for the process itself. So this is the example of temperature control using ladder logic, starting from the inputs, and then we have the outputs also as well for the heater. And then this value here indicates the number of temperature itself. The value of the temperature here. So it indicates in unit of Celsius degree. So as you can see, there could be a changing of there could be a changing of the output as the input, as the temperature changes as well. So let's say that the value of the temperature in here indicates or shows 603 degrees Celsius, and then we change it into 591 degrees Celsius. There should be a change in the output itself. The output actually regards into the magnetic field itself, as we have explained before. So there should be a changing in the behavior of the output. Dan videonya nggak bisa.
Yang benar.
Assalamualaikum warahmatullahi wabarakatuh. The title of our presentation is Timer. The reference that we get is Industrial Electronics by Frank de Petruzela. Okay, first, we are going to present about timer, which is used in PLC or any other controller device. A timer is a specialized type of clock for measuring time intervals. For example, stopwatch, digital timer, analog timer, and so on. Next, timers are used to delay actions. First one, keep an output on for a specified time after an input turns off. The second one, keep an output off for a specified time before it turns on. Next, on delay timer. This type of timer simply delays turning on. In other words, after our sensor input turns on, we wait some seconds before activating a solenoid valve output. For example, like press some switch and the light will be turned on after 5 seconds. So here we can see 5 second delay after giving input. This is called on delay timer. Next, off delay timer. This timer simply delays turning off. After sensor input sees a target, we turn on a solenoid output. When the sensor no longer sees the target, we hold the solenoid on for some seconds before turning it off. It means even turn off the switch, but to turn off the light 5 seconds if you set timer in 5 seconds of delay. Next, this is an example of on delay. In the above, there is an input and the output or timer in 5 seconds. In the below, there is a relay and a light. If this system is active, is like this. The input will be closed and the output will be active in 5 seconds. The relay will be closed and the light will be turned on. Next, this is an example of off delay. The input is normally closed and the output will be active in 5 seconds and trigger the relay open and the light will be turned off. This is the end of our presentation. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.